Good evening, class. Tonight we're going to learn about arithmetic series. Our I can statements for this evening are: I can understand the difference between a sequence and a series. I can find the sum of an arithmetic series. And I can use summation notation to calculate an arithmetic series. Now, why do we need to learn this? Well, because arithmetic series can be used when calculating interest and loan payments. An introduction. The story of Gauss. While in third grade, Carl Friedrich Gauss discovered a way to add the integers from 1 to 100 in a matter of seconds. Everyone in the class was asked to add the integers from 1 to 100 as punishment for misbehavior. In a matter of seconds, Gauss had the answer. It is said that Gauss wrote nothing but the answer on his slate, doing all the work in his head. Imagine the reaction of his teacher. Now, what I would like for you to do right now is just pause the video, and I just want you to take a moment to think about that and see if you can answer that question as quickly as Gauss did. These examples represent a finite series. A finite series is the sum of a finite sequence. The word finite looks a lot like the word infinity, and it's kind of the opposite. Infinity keeps going on forever and ever, whereas finite means that we stop. It means we have a set number of numbers that we're going to add in this series. The finite sequence means we have a set number of numbers in a pattern. That means like we could count the numbers in the pattern. Like if we had 3 numbers in a sequence, there are 3 numbers. I can count that. If we have an infinite amount of numbers, I can't possibly sit and count all those numbers. Okay, and this just means we're going to add them together. Okay, just like this. These 6 numbers, I can count them, so it's a finite amount of numbers. Okay, and it is a finite sequence. If I take and put plus signs in between them, okay, it becomes a finite series. And I add them all together, and we'd find out that their sum is 147. Okay, hopefully that makes sense. If you have any questions, make sure to mark them on your guided viewing sheet. Okay, we got the sum of a finite arithmetic series. We have a formula. Take note of it. S sub n, S stands for sum. The sum of the first n terms equals n over 2 times the quantity a sub 1, our first term, plus a sub n, our nth term. Okay. Now let's look at an example of using this, and this is a real world example here that we're gonna try and do. Okay. All right, so we got, if a college student borrowed $5,000 in loans. After graduation, the loan was repaid over a 100-month period with monthly payments as follows: $75, $74.80, $74.60, and so on till we get to the last payment of $55.20. Now, how much did the student pay over the life of the loan? Okay, so even though they borrowed $5,000 in loans, we need to realize that when you are loaned money, you have to pay an interest rate. That interest rate is like the bank or the, in this case, the educational institute, their way of making money for loaning you money. It's like their fee for allowing you to use their money. Okay, and then you're going to pay that money back plus your interest rate. Okay, so now let's go ahead and write down a few things that we know. Okay, first thing we should know is a sub 1 is 75. Okay, now a sub n equals $55.20. Okay, now since we took and paid 100 payments over this 100-month period, 1 payment a month, we're going to say this is n equals 100. Okay, so really this a sub n is really a sub 100. Okay, now then to solve this, to figure out how much money we paid over the life of this student loan, what we got to do is we got to use our formula. S sub n equals n over 2 times a sub 1 plus a sub n. Okay. Now, let's go ahead and plug in what we know. We got S sub 100 equals 100 divided by 2 times our first term of 75 plus our a sub n term, which is 55.20. Okay, now let's go ahead and use PEMDAS. So 100 divided by 2 is 50 times, let's go ahead and add these two things together. We got 75 plus 55.20. This is going to be $130.20. Now, let's times these two numbers, 50 times 130.20, and we get $6,510. Okay? So, as you can see, if we were loaned $5,000 and we paid in $6,510, this is what we were loaned. We were end up paying in interest payments, and all of our interest payments totaled $1,510. Let's review our I can statements. Our first I can statement was I can understand the difference between a sequence and a series. Guys, real quick, sequence, you're just going to see a list of numbers with commas separating them. With a series, you're going to see a plus sign showing that they're being added together. Okay, that's the big difference. Sequence is just a list. Series is a sum, or a list of a sequence being added together. Okay. Now, the second one, I can find the sum of an arithmetic series. Hopefully, you can do that now, being given that formula that we used. And we'll look at the third I can statement tomorrow night. Appreciate your all's patience and your attention. You guys have a good evening.